Hello, today I'm going to show you and explain how you do integration by parts. This is probably the only actual heavy equation integration, if you know what I mean. And if you look up it up on the web, look on Wikipedia, well, don't look on Wikipedia because they'll show you the American version most likely, but if you look at your formula book, you'll get something like this. You'll get u upon dv dx, and then they'll put in the integral, and they'll say that will be uv minus the integration uv minus integration of v upon du dx. And that's it. Things that you'll get stuck up here. First you'll ask yourself, why is that there? How can y equal differential? This is the thing about things being relative. I think something is only a differential because you think it is. Because everything is derived from everything else. Like, volume is three-dimensional, but when you put in, but we live in a four-dimensional world when you include time. So you could say that volume is there you get the volume when you integrate area, but you're still the differential of the world that we live in. You're still the differential of the fourth dimension. Like the fourth dimension is still the differential of the fifth dimension, if we ever discover one. So what you have here is just the way that we denote it. It's the main reason why we put it this way is because it would be really hard to explain that we're doing integration of a du dx multiplied with integration of v. That'd be a lot harder to write, and a lot more people would get it wrong. So basically, how I remember this, I just remember that, and I say to myself, well, it's got to be uv minus the integration of the opposite of that. And that's how it goes in my memory. However, it is in your formula book, so you don't actually need to remember it. And if you're not doing this under the test conditions, you can look up if you forget the formula, or just look at my video again. However, you should know these off by heart. So what does this actually apply to? This formula actually applies to a lot of things. It's essentially really good for many things, and it does have many applications. But essentially you need a u and you need a v to do it. Ish. Because remember again, everything's multiplied by something, everything's multiplied by 1. So you could get off that way, and the one for ln does do that. But let's just do a normal example. Oh, I forgot. For a lot of your specifications, you'd only be wanting to do this one integration round. You'll see what I mean in a minute. But you may get to the stage where this still isn't solvable in real life. Which is why you may want to think of which one to put your x and which one to put your dv over, to put your dv dx. Right. Because the whole point of this is to reduce one term. Because in integration, this integration uses differentiation, which actually has which normally has a reducing factor in a lot of things. X is an example of that. A lot of variance would be reduced. Sin x would not be reduced, it would keep on going. it would bounce the cost, bounce back the sign, change this negative to positive and all that, over and over and over again. It would keep on going in a cycle. But x would turn to 1. I'd be gone. So I'm going to make u equal to my x, and du by dx will just equal to 1. I'm going to make my dv by dx. Notice I have these two on the same line, because you're going from somewhere and then going to. On my sine x, and I find out my v. Now, integration has always been the opposite of differentiation. When we differentiate, we get cos. When we differentiate sine, we get cos. However, when we integrate sine, we get negative cos. A lot of people mess that up. Okay, so we got all we need, and we just solve this. So u times v would be minus x cos x, minus integral of the u. Sorry, that really does not look like a u. Minus integral of the volume, okay? Which is just minus cos x. The minuses, you can take them outside and they'll cancel, and they'll just be a cos x. dx, which naturally integrates to a positive sign. So that it will be a minus x cos x minus sine x. And remember your c. That is the most easy thing to forget. Right? And there you go, that's it. It does get a bit more complex than that. You have a bit more tricks. There's one integration which you kind of have to know how to do, well, one type, and that's the ln one. But you could be, if your specification has it in it, some of them make you do this twice. So for example, if you were given an x squared, you'd have to do it twice, because then here would still contain an x, and then you do the integration by parts on that. A bit like with chain rule, you can be expected to do a chain rule with a chain rule. Some of them do have that. So just be aware. And know that you can't integrate normally. That, and also if they ask you to integrate by parts, if they specify, you have to do it the whole way through. You can't do it half the way and then integrate this by like substitution. Okay? Naturally, I'll do more of these questions in the future. If they're not already up there at the moment, they will be at some stage. Like the video, enjoy them. Please have a look through my other videos. Like the only thing that's stopping the rest of the people from being helped like you were is that they don't know about it. So please show your friends and enjoy it.